Alright guys, today we're going to go over section 3.2, solving systems algebraically. That's using substitution and elimination. This is something that you should have seen before, should not be anything new, so we're going to go through it rather quickly since it is a review. Last time we solved systems by graphing and by looking at the tables. This is just one more way to get the same type answers. So we're going to start out by substitution. Okay, and I've got your steps over here for you on the left. See if I can zoom out just a little bit so you can get it all. Okay, so the system of equations they give me, you can see those there on the right hand side. Our first step is to pick one equation and isolate a variable. Well, when I'm going to do this by substitution, I always look for the variable that has a 1 coefficient. So I'm going to take this equation and get the y by itself. So when I move the 2x over, this is my new equation. Then I'm going to substitute that expression into the other equation. So I'm going to take this information, since it is equal to y, and I'm going to replace y in this equation with that information. So I've got 3x plus 4 times my negative 2x plus 10 is equal to 12. Notice I just took out this y and put this instead. Now I've got an equation that only has one variable, so I should be able to solve for x. So I'm going to distribute the 4. Combine my 3 and negative 8x will give me negative 5x. I'm going to go ahead and subtract this 40 from both sides. When I do that, that gives me negative 28. Divide both sides by negative 5, and that's going to give me 28 over 5, which can be written as a decimal since it doesn't need to be rounded. So I'm going to go ahead and do that. That's the x value for my system's solution. What I've got to do now is I have to solve for y. So I'm going to take this equation where I've already got y by itself and substitute this value for x. So take my equation, y equals negative 2x plus 10. I'm going to take out the x and put 5.6 in its place. 2 times 5.6, oops, this is a negative 2 times 5.6 gives me a negative 11.2 plus 10. Y is going to be negative 1.2. So now I know what x is and I know what y is. My answer should be written as an ordered pair. Your x value comes first and then your y value. If you plug this x and this y into both of these equations, you will get true statements for both. So here's a system that I want you to solve. I'm going to go ahead and solve it here in just a second. I'll pause mine, and you may want to pause yours while you work it, and then I'll show you what I ended up with up here. And if you have questions, you can ask me about it next time. Alright, so here's my work. I started out taking this equation because it had a 1 in front of the x, and I got x by itself this time. You don't always have to get y by itself. I get the variable that's easiest to work with by itself. So when I got x by itself, then I had to plug into this equation the information or the stuff that was equivalent to x. So I took out the x and I put in negative 3y plus 5, simplified and solved for y in this one. And then I had to take that information and plug it back in to solve for x. So I plugged it into this equation. And you can see over here where I did that. Took out the y, put in a positive 2.5, and solved for x. Here's my answer as an ordered pair. All right, next we're going to take a look at solving by elimination. And that's exactly what it sounds like it is. You're going to eliminate a variable. And once again, I've got the steps typed out for you over here. And for this problem, I want you to notice that your x terms have the same coefficient, only one is positive and one is negative. That is always our goal when we're starting to work with these problems and working them by elimination. We always want that to happen. So it's nice that this one starts out that way. So what I'm going to do is I'm just going to add these two equations together. My 4x plus negative 4x will cancel, and I end up with 5y equals 25. I can solve easily for y. Then I've got to take this and plug it back into one of the originals, and it does not matter which one. So I'm just going to use the top one. Since I know that y is 5, oops, let's try again. I'm going to take out the y, put a 5 in its place. So 4x plus 10 is 9. Move my 10 over, so 4x is negative 1. That means x is negative 1/4. My ordered pair will be negative 1/4, 5. This is your solution. And if you notice, because my answers are fractions here, this is one that would be hard to get by graphing or even looking at a table, because you don't normally graph things in decimals or in fractions. You can, but it's not always very easy. And your tables are not always set up in fractions. You can always adjust those, but elimination here for this one was so much easier. So once again, I'm going to pause the video while I work it. You may want to do the same while you work it, and then I will put my answers and work up here and see how you did. All right, here's your answers. This time my y's had opposite signs with the same number, so they would cancel. My x's combined to give me 3x. Over here I get 12. Divide both sides by 3, I know x is 4. I chose the second equation this time. I could have just as easily have chosen the first one, it doesn't matter. Plug it in. 5 times 4 minus 8y equals 20. Well, 5 times 4 is 20. I'm going to subtract that from both sides to give me negative 8y equals 0. When I divide both sides by negative 8, this is what I get. But you've got to remember, 0 divided by anything is just 0. That makes my ordered pair 4, 0. All right, so now we're going to take a look at equivalent systems. Get my sheet of paper up here. All right, equivalent systems is when one equation is a multiple of the other. So that's what we're going to need when we start working with problem number 4. Because if you'll notice, if I'm going to solve this by elimination, my x's don't have the same coefficients, the y's don't have the same coefficients. So I'm going to have to fix them so they will be the same. So I'm going to create some equivalent systems. So if I think, what number could I change this 2 and this 3 into so they would cancel? Well, I could change them both into a 6, by multiplying this by 3 and this by 2. Now one of them would have to be negative, but we'll worry about that in a second. I could also fix the y's if I wanted to. I could turn them both into 35 by multiplying this by 5 and this by 7. I would rather not use numbers that large, so I'm going to go with fixing the x's. So I'm going to multiply this equation by 3, and that will give me 6x plus 7y. Oh, let's try again because I have to multiply every part of it. 7 times 3 is going to be 21. So this is 21y. Also multiply by 3 over here will give me 12. Now for this equation, I also need a 6 here, but I want it to be negative. So I'm going to multiply that whole equation by negative 2. So I get negative 6x minus 10y equals positive 10. Now, when I add my equations together, the x's will cancel. I get 11y equals 22. That means y is 2. And then I want to go back to one of my original equations. Doesn't matter which of those originals you go to. Plug in for y so I can solve for x. I'm just going to use the top one. So 2x plus 7y equals 4. Take out the y, put 2 in its place. I'm going to move the 14 to the other side and divide by 2. So my solution is negative 5, 2. So all we had to do different for this problem was we had to get an equivalent system. So I had to make this equation, multiply it by something to get this one, positive 6, and multiply this equation by something so that I end up with a negative 6. So this whole system right here is equivalent to this one. I just had to pick numbers so that I could get things to cancel. All right, here's one for you to try. Again, I'm going to pause while I work it, and then you can pick back up with me in just a minute. All right, so here's my solution for this one. This solution would be easy to find by graphing, although I'm not sure how easy these equations would be to graph accurately. So as you can see, elimination works just fine for this one. And now, last two problems here. I want to talk about some systems that have some unique solutions. They just come out a little bit different. And these go pretty quick and easy. If you take a look by elimination, the x's and the y's cancel. You get 0 over here. Negative 5 plus 5 is equal to 0. Well, in this problem, the variables canceled. And that is a true statement. 0 does equal 0. That means there are infinitely many solutions. It means they actually graph the same line. For this one over here, once again, my variables cancel, giving me 0, but on the other side, I get 16. Well, 0 never equals 16. So when you have a case where your variables cancel, but you end up with a false statement, this is when you would have no solution. If you solved these, or this one, by graphing, you would actually end up with a set of parallel lines. All right, and that's it for section 3.2, guys.